This video is about L'Hopital's rule. With the help of this rule, you can calculate limits in a very elegant and simple way. So the rule is the following. We want to compute the limit of a fraction, and now x goes to a general variable a. And L'Hopital's rule can be written down in a very simple way. You just derive the numerator and the denominator separately. So in this case, you can compute the limit of this quotient as the limit of its derivatives. But the L'Hopital's rule is only valid when this quotient, if you evaluate it, the left side, is an indeterminate expression, 0 divided by 0, or infinity divided by infinity. If this is not the case, this rule doesn't make sense, so you will get nonsense. So note, this is no quotient rule. We actually have to separately differentiate the numerator and the denominator. What else I have to mention is this a can be numbers, but it also could be plus or minus infinity, or it could be right or left limits, like let's say you go to 7 from the positive side, so-called one-sided limits, or also from the negative side, so left limits. So we demonstrate this rule by using a very simple introductory example. We want to compute the limit of ln x divided by x. So first you plug in for x is infinity, and you see ln of infinity is infinity divided by infinity. So we have this so-called indeterminate expression. So the assumption for L'Hopital's rule is fulfilled. So we can separately differentiate the numerator and the denominator. The first derivative of ln is 1 by x. The first derivative of x is 1. And we actually already have finished. Because if you plug in infinity here, this goes to 0. So we have 0 divided by 1, which is 0. The next example is a typical rational function where the degree in the numerator is the same as the degree in the denominator. So we want to compute the limit of this fraction. You see the degree in the numerator is 2 and the degree in the denominator is also 2, so it's the same. You plug in x, you know in the numerator if you plug in x, only the highest power plays a role for the limit, so it's this one, 3x squared, and 3 infinity squared is infinity. The same in the denominator, what plays a role is 2x squared, the highest degree power. And this also is infinity, so the assumption of the L'Hopital's rule is fulfilled again. And we can differentiate the numerator and the denominator separately. By using power rule, we get this, and also power rule in the denominator. I want to point out that this is not the quotient rule. We do the differentiation separately independently in the numerator and in the denominator. Now we do it again. You plug in for x infinity, and you get in the numerator as above infinity, and in the denominator also infinity. And you see we can use the L'Hopital's rule again, so we use the rule twice. If you differentiate, the numerator is 6, the denominator is 4, so the limit is 6 by 4, which simplifies to 3 by 2. So we have used L'Hopital's rule twice here, and we got the answer. I just want to recall that you can also compute the limit of the fraction by computing the polynomial quotient. We did this by calculating the polynomial division, and then we actually just got these leading coefficients, because here the degrees are the same. Or you can also compute the limit by dividing by x squared in the numerator and in the denominator and taking standard limits, and you also would get 3 by 2 without using the L'Hopital's rule.